Okay, so today we're moving into some of the deeper applications of percents, or of decimals, I should say. One of them is going to be percents when we get there, but first we want to finish up a couple of things with decimals. We talked a little bit on Friday about powers, so I want to review here. If 15 squared is 225. Using what we learned on Friday, if I have 0.015 squared, what does that have to be? First of all, can anybody tell me how many decimal places it needs to have? So remember, squared means it's going to be times itself. We have 1, 2, 3, 4, 5, 6 decimal places. So then the 15 squared is 225. So that goes at the end, and we fill in the zeros. So that's 0.000225. That's an extremely small number. How can we take something like that, 0.015 or 15 thousandths, and square it and get something that's even smaller? Well, if you think about it, let's just take a look at what powers that just squaring even does to a number. We think of squaring something as making it larger. But remember, when we square it, it is simply multiplying by itself. So if I start out with a number like 5, if I multiply by 2, that gives me what? 10. It definitely does get larger. If I multiply by 1.5, can anybody tell me what that gives me? $7.5. Good. 1.2 then would be $6. Good. And of course, the easy one, 5 times 1 is 5. Now remember, we talked before when we were doing multiplying integers, negative numbers, about finding patterns because the definition doesn't work anymore. Here, the definition continues to work, but we also find a definite pattern here. And the break point in our pattern is right here when we're multiplying by 1. If I keep going, 5 times 0.8 will give me 4. Or 5 times 0.5 is what? Oops, I said 0.5, but I wrote down 0.2. 5 times 0.5 would be 2.5. And somebody said 5 times 0.2 is 1. Well, again, that break point of multiplying by 1, notice here when we multiplied by something smaller than 1, our numbers did not get larger, they got smaller. So if you're multiplying by something smaller than 1, you're actually reducing the size of the number. So when we go to take a power, if I have something like 1.5 squared, well, 1.5 is bigger than 1. So when I square it, I'm multiplying it by itself, so I'm multiplying it by something bigger than 1. So when I square it, it's going to get larger. 1.5 squared is 2.25. However, if I have 0.9 squared, 0.9 is smaller than 1. When I multiply it by itself, technically what I'm doing is multiplying it by something smaller than 1. So when I square 0.9, its result is going to get smaller. And we talked briefly about roots, square roots. The opposite is true when we do square roots. If I do the square root of 81, can anybody tell me the square root of 81? 9. Good. The square root reverses squaring. So the square root of 81 is 9. It gets smaller when we take its square root. We might have the square root of 6.25. I don't expect you to know that one, but if you punch it in your calculator, you'll get 2.5. Again, we get something smaller when we take the square root. But just like with the powers, there's that turning point at 1. Of course, the square root of 1 is 1. 1 squared is 1. The square root of 1 is 1. The value of 1, the power or the root has no effect on it. But if I go to something smaller, 0.81, when I square root that, I get 0.9. Because 0.81 was smaller than 1, square rooting it has the opposite effect. It actually gets larger. Just like when we got with our squares, when we got smaller than 1, it went the opposite way. They got smaller. So something to keep in mind as we're working with our decimals when we deal with powers and roots. So then the next step is to look at what happens when we take our decimals into our order of operations. Things that look like this. 9.6 plus 18.54 plus 12 times 0.4 squared over 6.8 times 0.8 minus the square root of 2.25. So here, order of operations still applies even though it's ugly decimals. We have this fraction bar, which as you've all said means divide, but it's also an enclosing symbol. We have to do everything on top first, then do everything on bottom, and then divide those. So let's start with everything on top. I'm going to rewrite that off to the side here. 18.54 plus 12 times 0.4 squared. What do we have to do first? Parentheses. Good. 12 times 0.4 is 12 times 4 would be 48, so 12 times 0.4 is 4.8. Good. Now we've reduced what's inside the parentheses to a single number. Can I take the parentheses away? I could. I would just have to remember to leave the squared on the 4.8. Of course, the next thing that needs to be done then is the 4.8 squared. What does that give us? 23.04. Good. And all that's left is to add. So we have 18.54 plus 23.04 is 41.58. So that's what we get on the top. On bottom, what do we have to do first there? The square root. And the square root of 2.25, 1.5. Still bigger than 1, so when we square root it, we get something smaller. What's next? Multiplication. 6.8 times 0.8. Is that 5.44? Good. And then, of course, all that's left is to subtract. What do we get? 3.94? So all that's left now, we've got that down to 3.94 on the bottom. All that's left is to divide. Before we do this division, I'm going to define that we want our answer to the nearest thousandth. Now, I realize that we went through how to do division with decimals. To be totally honest, I don't do divisions with decimals by hand if I can avoid it. I pull up the calculator. So here we would do 41.58 divided by 3.9, what do we, or 3.94, what do we get? To the nearest thousandth, what would it be? 10.553 looks good to me. So a little bit ugly because of the decimals, but no different than doing order of operations with our whole numbers. Well, we said that we can have other enclosing symbols. We saw one here, and we had parentheses, but we also had the fraction bar. Another enclosing symbol or potential enclosing symbol is the radical. And just like we can have parentheses inside of parentheses, we can do radicals inside of radicals. There, this one's just a little bit more difficult. So when we go to do this one, it looks like kind of a monster. But just go through the process. It's not as terrible as it looks. So we have the main square root symbol, the main radical here. We have to do, everything is inside of it, so that really doesn't separate anything out for us. It is an enclosing symbol, but it's enclosing the whole problem. So that just means once we've done everything inside, we have to do the square root and we're done. Next, we have the fraction bar. Oops, I didn't mean to erase it. We have the fraction bar across there. So that's separating the top from the bottom. So let's do the top first. So this part here. So the square root of 32 divided by 8 plus 9.34. So in there, what do we have to do first? What's 32 divided by 8? 4. Good. And then we add, so 13.34, and then square root. So the square root of 13.34 is not going to work out to be a nice number if I remember correctly. It does not. Now, we said we want our answer to the nearest thousandth, and we're going to stick with that on this problem too. Does that mean I should just round this to the nearest thousandth? Say no. No. Can anybody tell me why? Well, if I'm going to round to the nearest thousandth, I need to know what those next digits are past it. If I just round this to the nearest thousandth, those round-offs can build up and affect my answer very poorly. A lot of textbooks will tell you have to go at least one digit past where you're going to round. Most engineering texts go 2 digits past where you're going to round. And that's usually a better rounding here. So that is 3.652396. What digit there is the thousandth digit? The digit in the thousandth is the 2. So to go 2 digits past that, we do the 3 and the 9, and we would round there. Give us 3.65240. Because that's a 9, this is a 6, rounds that 9 up to a 10. We have to carry the 1 to make that a 40. So the top of that becomes 3.65240. So now let's look at the bottom. Down here. And of course, we have the enclosing symbol with the root there as well. So we're going to have to start inside there. What do we do first inside that root? Well, we see parentheses, so we have to go in there. What's first inside the parentheses? Division, 6.56 divided by 1.6. It's 4.1. Perfect. Oops. So 4.1 minus 3.1 is what is left inside that radical. Or inside that parentheses, I should say. All that's left is to do that subtraction. What do we get when we do 4.1 minus 3.1? 1. There we go. And just to save time, what's 1 squared? Just 1. Perfect. So we have completed that parentheses. We've taken it out. We didn't need anything else put in there. Now we're back out to working under this square root. All that we need to do there is what? $4.3 plus 1 makes 5.3. Good. Now we have to do the square root of 5.3. So again, this one's not going to work out nice and neat. So we're going to have to round it. Where would we round that to? So we want to go 2 digits past the thousandths. So this is the tenths, the hundredths, and the thousandths here. 2 more digit would be the 1 and the 7. If we round there, that's going to be 2.30217. That's where we'll round that for now. Two digits past where we want our final answer to be rounded. Now what? You can just add. 14.7 plus 3.1 is 17.8. And then we subtract. 17.8 minus 2.30217 is 15.49783. That is the whole bottom of this has reduced to that. 15.49783. The top part was 3.65240. And of course, there's still a square root around the whole thing. What do we do next? Divide. Good. So we're going to divide that. 3.65240 divided by 15.49783. Now again, we want to divide this to 2 digits past our final answer. So 2 digits past the 1,000. So that's what? 235671. 0.235671. This is tenths, hundredths, thousandths. We go 1, 2 more, and we round it off there. That would be 0.23567. And of course, the last thing we need to do is square root. Now, if we didn't want to round it off, one thing, if you don't want to type that back in your calculator, most of your calculators, especially after the Texas Instruments, but the Casios have them as well, have a key that recalls the previous answer. So I can enter my square root symbol here, then in my calculator hit the second key, and then way down here by the enter key it says ANS. I hit that key, and it uses the previous answer. So rather than having to write that down and type it back in, I can just tell it take the square root of the previous answer and hit enter. I get 0.48546. And this one comes out to a spot where a lot of students make a bad mistake. What I see happen often is something like this. I want to round to the nearest thousandth. But this 6 tells me I should round that up to a 5, and then that 5 would tell me to round this up, wouldn't it? Is that correct? A lot of people would do that, but remember, when we talked about rounding, what it's actually saying is on the number line, which one are we closest to? This is 0.485. This is 0.486. Right in the middle would be 0.4855. Which side is the 0.4846? Is it on this side, the left side, or the right side?
The left side.
It is on the left side. So it's going to round to 0.485. That's the one it's closer to. So when you're rounding, the only digit you need to consider is the one digit past what you're rounding to. So 0.485, the next digit is a 4, so we round it down to the 5. We keep it to 5. Any questions on that? Okay. Okay, so our next step then, we're going to move on from those and we're going to start into percents. Understanding percents involves understanding the word itself. It's actually two words, per. If you think of miles per hour or miles per gallon, it's for each or out of. And cent. If you think of years in a century or cents in a dollar, that is 100. So the word percent literally means out of 100. So if I have 34%, what that actually is saying is a ratio of 34 out of 100. Now, of course, we wouldn't leave it as 34 out of 100 if we were changing it into a fraction. We would do, both of those can be reduced by what? $34 and 100 can both divide by 2. Good. 34 divided by 2 is 17. And 100 divided by 2 is 50. Good. So 17 out of 50. Now, many textbooks mistakenly call this the fraction. And it's a fractional form, but it's not a fraction. What it really is a ratio. Because the percent itself is actually a ratio. 34% is actually that ratio, 34 out of 100. This is just the reduced form of the ratio form of 34%, or 34 out of 100. Now, not all of our percents are that easy to put into that ratio form, or fractional form, if you prefer. Taking something like 65%. Of course, putting it into the fraction form, 65%, is 65 out of 100. The percent always means out of 100. So now both 65 and 100 can be divided by what? 5. Good. 65 divided by 5 is 13. And 100 divided by 5? 100 divided by 5 is 20. So that reduces to 13/20. Well, we can run into weird stuff like 380%. Now, we know that if it's more than 100%, it's more than the whole thing. 100% would be the whole thing, or 1. So 380% is going to be more than that. But it still starts out as 380 out of 100. And then we're going to have to reduce it, but it's also an improper fraction. We can turn it into a mixed number. It's probably easiest to do the mixed number at this form because you're dividing by 100. How many times does 100 go into 380? 3 times, right? With how much left over? 80. Good. So like I said, when you're dividing, when the denominator is 100, it's really easy to bring that from a improper fraction down to a mixed number. Now we can still reduce the 80 hundredths. Both 80 and 100 can divide by what? 20. Good. 80 divided by 20 is 4. 5 divided by 20? 5. What do I still need to remember? The 3. So 3 4/5 is what that would be reduced to in that fractional form or that ratio. Let's look at 36 2/3%. If I want to put that into a ratio or fractional form, it's still a percent, even though there's a fraction in it. So it's 36 2/3 out of 100. Now, we don't like having fractions within our fractions, so we'd prefer to reduce that. There are a couple of methods we could use. The simplest one is probably to just divide it. Remember, we mentioned last week that a fraction and a division problem are interchangeable. So we can just turn this into 36 2/3 divided by 100. Now, of course, I'm going to make this 100 over 1. 36 2/3, can anybody tell me how many thirds that becomes? $36 times 3 is 108 plus 2 is 110. Perfect. Then, of course, dividing by 100 over 1, we multiply by the reciprocal, so times 1 over 100. Yeah. Both of those, the 110 and the 100, can be divided by 10, giving us 11 here and 10. So we multiply. 11 times 1 is 11. 3 times 10 is 30. So 36 2/3% is 11 out of 30 as a ratio. Or we might have 56.25%. Well, when we put this into a ratio or that fractional form, it's still 56.25 over 100. But just like we didn't like to have decimals or fractions within our fractions, we also don't like to have decimals within our fractions. The simplest way to get rid of a decimal is what we did when we were dividing by our decimals. Got some reverse twerking going on there? Sorry. Private joke. So anyway, we need to get rid of that decimal. And the easiest way to get rid of the decimal is what we did when we were dividing fractions or dividing decimals. And that's move it over. And we move it over by multiplying by 10 or 1,000 or whatever. Here we have 2 decimal places. So to get rid of 2 decimal places, we would multiply by, will 10 do it? We need to multiply by 100. So the 56.25 times 100 is 5,625. 100 times 100 is 10,000. Both of those now can be reduced by what? 5 will work. So that gives us 1,125 over 2,000. Both of those can still be reduced by what?
25.
25 will work. Oh, let's see. What does that give us? 45 over 80. Then what?
80.
Both of those can all still divide by 5. What does that give us?
9 over 16.
9 over 16. Perfect. 9/16. So 56.25% put into that fractional or ratio form is 9 out of 16. So in your notes, I want you to try 2 of them quick here. Actually, we want you to try 3 of them quick. I will do 425%. Put that into that fractional or ratio form. 18 1/3%. And 12.5%. I'll give you guys a minute or so, then we'll go over those. Let's take a look and see how you're doing on these. So for the first one, 425%. Of course, that becomes 425 out of 100. Again, this is probably the easiest spot to break it down into a mixed number. So 100 goes into 425 4 times, with 25 left over. 25 over 100, both of those can be divided by what? 25. Good. And that'll give us 1 over 4. And of course, we got to remember the whole number of the 4 out front. So 4 1/4 is what that gives us. 18 1/3% is 18 1/3 over 100. So now the easiest way to deal with that is to turn it into a division problem. 18 1/3 divided by 100. 18 1/3 becomes how many thirds? 55. Good. Instead of dividing by 100 over 1, I'm going to multiply by 1 over 100. And here we notice that 55 and 100 both can be divided by 5. 55 divided by 5 gives us 11, and 100 divided by 5 is 20. So 11 times 1 is 11, and 3 times 20 is 60. Good. So 11 60ths, 11 out of 60. Next we have 12.5%, which of course is 12.5 out of 100. What's the first thing we have to do with that? Multiply by 10 to get rid of the decimal, make it 125 over 1,000. And both of those can be divided by if you look really closely, they can both be divided by 125. Gives us 1 over 8. Or you could have divided by 5 a few different times, you'd still get to 1/8. So 12.5% is 1 out of 8. The good news is converting that percent into that fractional form or the ratio is probably the most difficult task in dealing with percents. Let's look at going from a percent to what most books call a decimal form, but it really is not a decimal. What it really is it's something called a rate. So when you hear the term rate, what it is talking about is what you're used to seeing as the decimal form of a percent. So if we go back to that 34%, remember that means 34 out of 100. Well, the rate is just the decimal form of that. To turn a fraction into the decimal, it's just the numerator divided by the denominator. So 34 divided by 100. Well, when we divide by 100, what does it do to a number? It simply moves the decimal point 2 spots, doesn't it? So that becomes 0.34. Well, since every one of our percents is out of 100, every time we go to convert a decimal into a rate, we're going to be dividing by 100. So it's just moving that decimal point 2 spots to the left. So if I have 73%, what does that become as a rate? 0.73. Good. If I have 8%, what does that become as a rate?
0.08.
0.08. 210% as a rate will be
2.1.
2.1. 0.7% will be what as a rate?
0.007.
0.007. Good. 3.9% will become 0.039. Now, here's the one I catch a lot of people on. 1/4% is, what is a rate?
0.25.
Careful.
0.25.
You got it. 0.25 would still be a percent. It's 0.0025 is a rate. You did exactly what most people do, is they just want to jump to the 0.25. When I deal with percents, one of the things I talk about a lot is called benchmarks. And a very common benchmark is 1%. And of course, as a rate, 1% is 0.01. If I compare that to 1/4 of a percent or 1/4%, 1/4% is smaller than 1%. So its decimal form has to be smaller than 0.01. Well, how about going the other direction? If I have a rate and I need to get back into a percent. So let's say I have a rate like 0.27. What that means is a rate is out of 1. So the rate of 0.27 means it's 0.27 out of every 1. If I want to convert that back into a percent, well, percent is out of how many? Out of 100. So we have to multiply 1 times 100 to make 100. We have to multiply the 0.27 times 100 to make 27. So that's 27 out of 100, or 27%. Once again, every time we go to convert a rate into a percent, we're going from out of 1 to out of 100, so we're just going to be multiplying by 100. Multiplying by 100 has the opposite effect as dividing by 100. Just moves the decimal point back 2 spots to the other direction, to the right. So if I have a rate of 0.78, what does that become as a percent? 78%. A rate of 0.4, what's that become as a percent? 40%. There we go. 3.2, what's that become as a percent? 320%. 2 spots to the left, to the right, you got to add the 0. 0.074 as a rate, what's that become as a percent? 7.4%. 0.003 becomes what as a percent? 0.3%. There we go. So going from that rate to a percent, you're just moving the decimal back to the right 2 spots. Finally, let's look at taking fractions back into percents. And let's start with one that pretty much everybody knows. 3/4 is what as a percent? 75%. Good. Now, if you didn't know that, there's a couple of options. You could have done 3 divided by 4 to make a decimal of 0.75, and then move the decimal point that 2 spots to turn it from a rate into a percent of 75%. Or you could remember that 3/4 is actually a ratio. It's 3 out of 4, and a percent has to be out of 100. And just like any other fraction, we could ask, what do you multiply 4 by to turn it into 100? To make 100, it's 4 times 25. So then we do 3 times 25 gives us 75.
75.
Yep, so 75 out of 100, or 75%. But not all of our denominators are going to multiply that easily to make 100. What if I have 5/8? Can anybody tell me what you multiply 8 by to make 100? Go for it. You're probably right.
12 and a half.
12 and a half or 12.5. You got it. And of course, I saw what you were punching in there. You found that it's not one of those that you're going to know off the top of your head like the 25. You found it by typing in 100 divided by 8, didn't you? To get the 12.5. And so this leads us to a shortcut process that we use for this. We're going to also then multiply the 5 by 12.5 to get 62.5. So that is, at this point, 62.5 out of 100, or 62.5%. But if we look a little more closely at what we did here, we had 5 over 8 and blank over 100. What we did to figure out what we were going to multiply the 5 by was we took this number, 100, divided by this number, the 8. 5 times 100 divided by 8 gave us that 62.5. And so this leads us to a shortcut if we look at where these numbers are located. The parentheses really don't affect anything here because of the order of the operations in it. So what we're doing is taking 5, the 5 times 100, and then dividing by the 8. And if we look at how those are located in our setup here, this type of setup is what we call a proportion. A proportion is any time we have two fractions that are equal to each other, or in this case, two ratios that are equal to each other. And when that happens, we have a number that's missing that we're looking for. That's the one right there. And what we'll do is we'll take that number that's missing, and we see that there's a number that's diagonal to it. That's the 8. We're going to use that later. Then we look, there are two numbers that are diagonal to each other. In this case, that's the 5 and 100. We multiply those two together, 5 times 100. And then we divide by that third number that was diagonal to the piece we're trying to find, divided by 8. So 5 times 100 divided by 8 is at 62.5. This process, of course, is a shortcut that I'm sure you've all heard before, called cross multiply and divide. This is one of the other processes. Remember we did fractions. I said there's other processes called cross multiplying. So that's why we use the term cross canceling. Here is that one of the processes they call cross multiplying. Okay, well, for that we have about 13 minutes left here. So I'm going to give you your homework. Your homework is all out of the big book. So in the big book, page 153 through 154, it's labeled Exercise 3-19. Page 1, we'll skip that one. We don't need to beat that one to death. Let's jump up to actually then page 218. This will be in the unit exercises, 1 through 23, the odds. The exercise 319, that'll be 7 through 37, the odds. If you're still working on that quiz, feel free to take this time to work on that quiz if you need to. Otherwise, we'll turn in those quizzes when you come in on Friday. So you guys have the last 10 and a half minutes here to get started, and then we'll let you out of here at 2:20.